In this lecture, we're going to start chapter 3, which is formal proofs. And section 3.1, we're going to start with valid argument forms, and this is going to be part 1. So what we're going to be doing is we're going to be formally proving that an argument is valid. And we're going to use tautologies. And we covered tautologies in the previous chapter. So remember, when we can show that a statement is always true, right? Regardless. So, for example, if we have a compound statement, and if we show that it's always true, regardless of the truth values of the variables, that's a tautology. So there is going to be a handful of tautologies that we're going to use as valid argument forms when we're constructing formal proofs. The first one is modus ponens. This tautology can be represented symbolically as P implies Q and P. So if that's the left-hand side of this conditional statement, so if P implies Q and P, then we can conclude Q. So I'm not going to go through this whole truth table, but this truth table shows that modus ponens is a tautology. So look, this statement, if P implies Q and P, then Q, it's always true, right? Regardless of the truth values of P and Q. So we have a tautology, which we learned about previously, right? Another way that we can express the tautology or this particular tautology in argument form is P implies Q and P, right? So if we have the premises P implies Q and then P, we can conclude Q. So this is how we would express this in argument form. So think of this as if we have a conditional statement, P implies Q, and then I have another statement, which is the left-hand side of the conditional, then we could conclude the right-hand side of the conditional statement. So that's the pattern for modus ponens. So why don't we just practice identifying this argument form? So are the following arguments an illustration of modus ponens? And oftentimes we're going to use MP for modus ponens. This way we don't have to write it out every time. So is this first argument a form of modus ponens? So remember, the key is if we have a conditional statement and then a single statement, right? And the single statement is the left-hand side of the conditional, the conclusion should be the right-hand side. So do we see that pattern here? We do, right? Because we have not P is the left-hand side of this conditional statement, right? And we're concluding Q. So it follows that pattern. So yes, this is an example of modus ponens. Let's look at the second argument. So we have if P then Q, and then we have Q, and therefore we're concluding P. So is this modus ponens, an illustration of modus ponens? And you'll see that in this case, it's not, right? Because even though we have a conditional statement, right, and a simple statement, it's Q is not the left-hand side, right, of the conditional statement above. So this doesn't follow that pattern. Let's look at one more. So for this one, we do have a conditional statement. The left-hand side is not R or S. And then my other statement is also not R or S. So if this is modus ponens, then the conclusion should be the right-hand side, which is W implies B. So this follows that pattern, right? So yes, this would be an example of modus ponens. So all we're doing right now is just practicing identifying if these arguments are an illustration of modus ponens, that tautology. We have another tautology called modus tollens, and we're going to abbreviate that as MT. And this could be represented symbolically as if P implies Q and not Q, then not P. So if we were to construct a truth table, which I did below, we would see that that last column, right, for that argument is always going to be true, right? So regardless of whether P or Q are true or false, right, whatever the combination is, we're always going to have the same conclusion. That statement is always going to be true. So we have a tautology. We can also express this tautology in argument form. So if P then Q, so that's going to be my first statement, and then we have not Q, which is the negation of the right-hand side of the conditional, and then our conclusion would be the negation of the left-hand side of the conditional, not P in this case. So that's what the pattern looks like for modus tollens. So let's just practice identifying that argument form. So let's look at this example. So are the following arguments an illustration of modus tollens? So for this one, remember, we have a conditional statement and then we have a simple statement. And the simple statement's going to be in the negation of the right-hand side of the conditional. And our conclusion should be the negation of the left-hand side of the conditional statement. So if we look at this first example, that's exactly what I have here, right? So we have the right-hand side of the conditional statement is Q. My simple statement is not Q. And then my conclusion is not P, which is P, right? So yes, this is an example or an illustration of modus tollens. Let's look at the second example. We have a conditional statement. The left-hand side is P, the right-hand side is Q and R. Now my other statement, right, my second premise is not Q and R. So it's the negation of the right-hand side. So far that looks like modus tollens, right? So if it is, the conclusion is going to have to be the negation of the left-hand side, which is not P. So yes, this follows the pattern, right? So that's an illustration of modus tollens. And then let's look at one more example. So we have a conditional statement, and then we have a simple statement, right? But the simple statement is not the negation of the right-hand side of the conditional, right? So right away, we don't see that pattern. So this is not an illustration of modus tollens. So now let's practice using these arguments when we construct formal proofs. So now I'm going to introduce how to construct a formal proof. And we're going to have a whole bunch of different valid argument forms. So these tautologies that we're going to be able to use to construct these formal proofs. So we've been, up until this point in chapter 2, we've been constructing or looking at these arguments, and we've been determining if they're valid or not just by assigning, true, false values, right, to each one of our premises. And then, well, the simple arguments in there, right? The simple statements, and then, or the single variables, with ultimately, trying to show that if what my premises are true, the conclusion has to be true as well, right? Then we have a valid argument. But we're going to take it a step further now. And once we use that method to determine if an argument's valid, we're going to construct a formal proof. So we're basically going to give reasoning as to why, we're showing these arguments are valid. So to show a formal proof for an argument's validity, we construct a sequence of true statements as well as reasons for their truth. And we're just going to put it in table form. So for this first example, Let's use the true-false method to test each of the following arguments for validity. If the argument is valid, we're going to show a formal proof. If it's not, in other words, if it's invalid, we'll provide a counterexample chart, just like we were doing in the previous chapter. So let's start with this first argument. So we have the following premises, right? So we have not A, we have not A implies B, and then we have C implies not B, therefore the conclusion is not C. So first of all, let's see if this argument's valid, right? So remember, the way to do that, let's assume that all my premises are true, right? Now we have to see if, when this is the case, we're forced to have a true conclusion. So not A is true, right? So then not A over here is also going to be true. Now for this conditional, not A implies B to be true. If the left-hand side is true, then B also has to be true. It can't be false, right? Or else that premise would be false. So if B is true, then not B is false. And C implies not B has to be true, right? Because it's a premise. Therefore, C has to be false. Otherwise, if it were true, true implies false would be a false statement, right? So C is forced to be false, which makes not C, our conclusion, true. So we just showed, right, that this argument's valid. But let's formally prove it. So we're going to construct a formal proof. So the way we do that, so we have to construct a sequence of true statements. And why are they true? So we start with a column where we're going to list our statements that are true. And then right next to it, in the other column, we're going to list our reason why they're true. And we're just going to number them. So now I'm going to get rid of, well, my markups here, right? So we have three premises that we're assuming are true. And we're trying to show that the conclusion is always going to be true as well, right? So I'm going to start with just the first premise. I could say that not A, that statement is true. And the reason for it is because it's a premise. So what we're trying to do is we're trying to list a bunch of true statements in order to come to the conclusion, right? In this case, not C, and show that not C is true. So we want to lead ourselves to listing our conclusion as a statement, right? And have valid reasoning for it as to why it's true. So I also see that not A is the left-hand side of this conditional statement, right? So I'm thinking, okay, maybe modus ponens, modus tollens, right? Because that has a conditional statement and then a simple statement, right? But I see the left-hand side is the same as my simple statement, right? So let's just remind ourselves over here in red. So remember, I'll just put it up here. Modus ponens is when we have P implies Q and P, then we could conclude Q. And then modus tollens says that if we have P implies Q and the premise not Q, then we could conclude not P. So let's just have those in front of us just so we could refer to them. So I'm thinking, okay, let me just change back to blue. For number 2, I'm going to list my premise, not A implies B. And I know it's true. My reason, again, is because it's a premise, right? We're assuming all our premises are true. But from there, I can also produce the statement B, right? Because I could use modus ponens. You see how I have not A, which is the left-hand side of the conditional, and then I have not A, which follows modus ponens, right? So we could conclude B. So the reason is, and I'm just gonna, shorten, instead of writing out modus ponens, I'm just gonna use MP. But we have to say which statements we used. So we're using modus ponens on statements 1 and 2. And our result is 3, right? B. And if you want, you could go through and check off the premises that you use in your argument. This way, you know that you've already used them. So now I'm thinking, okay, we somehow have to get to not C, our conclusion, right? But we didn't use that third premise yet. So if I list C implies not B, I know it's true because it's a premise. But look, I could put statements 3 and 4 together using modus tollens, because you see how not B is the right-hand side of this conditional statement, and then B is the negation of not B, right, of the right-hand side, which is modus tollens. So the result is going to be the negation of the left-hand side. So we're going to negate the left-hand side, which is C. So we're going to get not C, which also happens to be our conclusion. So we just showed that our conclusion was true, right? And that last reason was modus tollens. And we use that on statements 3 and 4. So that's our reasoning. And that concludes our formal proof. And we're going to keep practicing. So let's look at the next argument. Let's check the validity, because we can only make one of these formal proofs, right, if it's a valid argument. So let's see if this is valid. So let's assume all the premises are true. So if not W is true, then W is going to be false, right? Therefore, S has to be false because we need that conditional to be true. So then S over here is false, which would make not R false, which would make R true. And then P has to be true in order for that conditional to be true. And P is our conclusion. And we just said that P is true, right? So we just showed that our argument is valid. But let's make a formal proof. So let's list our statements and then our reasoning. Let's clean this up a little bit. Okay. So we ultimately want to show that P is true, right? A lot of times it's nice to start with just a simple statement, right? So just a single letter or variable. In this case, it's my fourth premise, right? We just have not W. So let's start with that, because it's always nice to look to put that together with another type of compound statement. So let's start with not W, and it's true because it's a premise. I'm just gonna start calling premise, PREM. Now let's look for, and we could check it off. Now let's look for another premise that contains W. So I see this premise number 2, so S implies W. So I'm going to state that that's true because it's a premise. Now look, that to me, when I look at 1 and 2, those two arguments, those two statements together, right, that forms modus tollens, right? So we have a conditional, and then my other statement is the negation of the right-hand side of the conditional. So we have not W, right, which is the negation of W. So if we apply modus tollens, then we're going to negate the left-hand side of the conditional, so we're going to get not S. So the reasoning is modus tollens on statements 1 and 2. So now, since I have not S, I'm thinking, okay, let me look for another premise that we didn't use yet that contains S, and that's the third one, right? So I'm going to list not R implies S. And the reason it's true is because it's a premise. Now look at 3 and 4. 3 and 4 look very familiar again. I have in 4 a conditional statement, the right-hand side is S, And then in 3, I have not S, so I have the negation of the right-hand side. So that's going to be modus tollens again, right? And the result, the conclusion is going to be the negation of the left-hand side. So the negation of not R, and not R is going to be R. So we can assume that R is true based on modus tollens using statements 3 and 4. Now, the only premise we haven't used yet is the first one, right? And it contains R, so I'm going to list it. So 6, we're going to have R implies P, and it's true because it's a premise. And look at 5 and 6. What valid argument form does that look like? That looks like modus ponens, right? The left-hand side of the conditional is R, and so is that simple statement, right? R. So then the conclusion is going to be P because of modus ponens on 5 and 6. And P is my conclusion, right? So we just showed that P is true formally with reasoning. Let's look at the next one. Let's see if that argument is valid or not. So let's assume the premises are true. So the fact that not W is true means that W is going to be false. That's the right-hand side of a conditional, which is forcing the left-hand side to be false, right? It can't be true or else the premise would be false. So if not A or B is false, then A or B has to be true. So then not R can be true or false, right? Because true to true is true, but false to true is also true. And R happens to be the conclusion. So if not R is false, then R would be true and we'd be good, right? But there's the possibility that not R is true, making R false. And then my argument would be invalid, right? So when does this happen? So let's produce a counterexample chart. So we have A, B, R, and W. Now we know R would have to be false, right? In order for this argument to be invalid. And we already determined that W is false. Now we don't know what A and B are, right? And A or B has to be true, which means that A could be true or B could be true, right? A or B could be true, and we'd still have A or B being true. Or if R is false and W is false, right? Because they have to be false. What if A was true, but B was false? A true or false is still true. Or what if the A was false and the B was true, while R and W are false? Right? So there's actually 3 different counterexamples in this case, where my premises would all be true, but my conclusion would be false. So in this case, we can't, provide a formal proof because we don't have a valid argument. So this argument is invalid. So let's look at one more. So let's look at this argument right here. Let's see if it's valid or invalid. So let's assume our premises are true. So if the third premise, not P or R, is true, then that makes P or R false, right? Because that's the negation, which then makes S false, has to be false, because if it were true, then true to false would be false. So then S up here is false, which forces not Q to be false. And then Q would be true, right? So when my premises are true, my conclusion is going to be true. So we have a valid argument. Now let's make a formal proof. So let's list our statements and our reasoning. And let's clean this up a little bit. So now let's think about, all right, where should we start? Which statement should we start with? We don't have a single simple statement, right? We have some compound statements here. But you see how we have a conditional statement for the second premise. The right-hand side is P or R. And then the third premise is just the negation of the right-hand side. So I'm thinking modus tollens, right? So why don't we start with these two statements? So statement one is going to be S implies P or R. It's a premise. And then two, we have not P or R. Again, another premise. That's why it's true. But you see the pattern here, if we put them together, right, that's modus tollens. So we're going to have our result, the conclusion is going to be the negation of the left-hand side. So we're going to get not S. So that's modus tollens on statements 1 and 2. Now we're trying to get to Q, right? We want to show that Q is true. And I have one more premise. Not Q implies S. And I see that 3, right? Statement 3, not S, is the negation of the right-hand side of the conditional in 4, right? S. So when the right-hand sides are, negations of one another, well, the right-hand side and that simple statement, right? We could think modus tollens again. So the conclusion is going to be the negation of the left-hand side of the conditional. So not Q is Q. And that's our conclusion, right? So we just showed our conclusion is true by using modus tollens again on statements 3 and 4. And that would conclude our formal proof. So let's do one more example before we wrap up, and then you'll have, exercises in the homework to practice with. So here I pretty much set up half of it for you. So we have the argument, it's valid. Here's our statements. Let's just provide the reasoning. So why is the first statement A implies B true? Well, it's because it's a premise. And then the second statement, A implies B implies not W, is also a premise. But now we have not W. That's not a premise, right? So let's think, okay, what could we do with 1 and 2, right? Well, A implies B is the left-hand side of this conditional. So they're the same. So I'm thinking modus ponens, right? So the conclusion should be the right-hand side of the conditional, not W. And it is, right? So this is an illustration of modus ponens on statements 1 and 2. So 4 is a premise, right? It's the fourth premise, not W implies R or S. And again, look at what I see here in 3 and 4. You see how the left-hand side of the conditional matches with that simple statement. Again, modus ponens, right? So the result is going to be the right-hand side of the conditional, which is R or S. So modus ponens was applied to 3 and 4, statements 3 and 4. And then 6 is a premise. And then now where did 7 come from? Not P. Well, I'm looking at 5 and 6 and I see, okay, the right-hand side of this conditional is not R or S. And then the simple statement is R or S, right? It's the negation of not R or S. So I'm thinking modus tollens, right? That's when we have the negation, that the simple statement's the negation of the right-hand side of the conditional, and then the conclusion is going to be the negation of the left-hand side. So the negation of P, which is going to be not P. So this was an illustration of modus tollens on statements 5 and 6. And then that wraps up the reasoning, that justifies that this argument is valid. And this would be the formal proof. So this wraps up section 3.1. We're going to continue over the next few sections, just adding more of these argument forms. That's going to help us, through our reasoning process when we're trying to, construct a formal proof.